There we go. Okay, let's get going. So this is Dora about a week ago when we did have some nice snow on the ground and it was a beautiful day. We're down at Victoria Park. If you don't know Victoria Park, Robbie Burns Park, that's the statue that's in behind Dora, down at the corner of South Park and Spring Garden Road. Behind us would be the public gardens. Anyway, one of the few occasions we were closer to downtown. Let's get going. Here we go. So what is day 10? This is, I'm presuming it's Wednesday, February the 8th, though I'm recording it earlier than that. The only thing interesting today seems to be it's Laugh and Get Rich Day. I had never heard of that one before, but laughing is good for you. And we just take life too seriously. We got to laugh more. It's actually good for your health. That's what they say. So what's happening over the rest of the week? This is a crazy busy weekend for sports. We've got lots of things going on in terms of men's hockey, women's volleyball. They've got a lot of games going on. Friday, Saturday, Sunday, it's a crazy weekend for them. And basketball, we've got a whole bunch going on against Dalhousie, which might be worth paying attention to. I'm not sure why we play. Oh, I've got the same game twice. I stole from listing that was on the university website. They must have it up twice. Anyway, no, they've got Sunday that, I don't know, we've got 2 games on Friday, I think. And, or is it Friday, Saturday, Sunday? Oh my God. Anyway, there is one thing that is this evening, if you're getting this, that is, I think, important for you. And that's the Commerce Society. They've got what they call Banking Industry Night. I know this isn't very clear as an image, and I'm not sure how to find it online. It wasn't on the university's official list of events. But the Commerce Society has got 2 alumni coming in. I think one's from RBC, the other one maybe Bank of Montreal. But one just graduated a couple of years ago, and the other one about 10 years ago. And they've both got really good positions in the banking sector. If you're an accounting or finance major, you might be seriously interested in this. Although banks do employ a variety of people. My niece, when she graduated quite a few years ago, she wasn't in accounting and finance, but she got a position with TD, I think it was back then, and was into mainly assisting people with mortgages, car loans, that type of thing. But she understood the banking sector well. And after a couple of years with them, got picked up by a car dealership as their one of their business managers to assist new car buyers with financing their automobiles. And she ended up, her career took off because she was incredibly good at sales. And car dealerships make a very large proportion of their income from not just selling the car, but the extra services that go with it. Anyway, she's had an amazingly good career in sales. But it was actually through banking that she got her foot in the door into very, very good sales roles. Anyway, the other thing is there is a workshop going on Friday afternoon. I don't know if you're going to go to a Friday afternoon workshop, but it's supposed to be on helping you with writing tests and exams, which I've tried to downplay a bit in the course, but I know is a big stressor for many students. And we sometimes wonder, are we testing you on the knowledge or testing you on how good you are at writing tests? But it would be worth a look if you've had problems with tests before. So let's get on. What else do we have going on here? So we've got a discussion due today on cause and effect. And I think this was one about, and there's a lot of research that if you take 5 courses, you're more likely to graduate on time. Governments like that. And in the US and in Nova Scotia, I'm not sure if they still do it, but they did for a time, reward you for finishing quickly. So they think it's a good idea to force you. In the US, they started penalizing students that didn't take a full course load, at least in one state. I think some of you might have questions about that. So does it really make that sense? We see the correlation. Correlation is definitely there, but is it what they think it is? We have a test coming up on Friday, chapters 3 and 4. In the past, students have had a lot of difficulty with this test, particularly on pivot tables. I've tried rewriting questions, changing them around. Hopefully it's a better test than before. But if it ends up everybody has trouble on it, then that's my problem, not yours. I'll fix it. And of course, you've got another chapter quiz due on Saturday. So last day we went through box and whisker charts. They are very popular now, at least among data miners, and I'm actually seeing it starting to appear in professional reports as ways of comparing multiple groups when we want to compare not just the average, but the variability around that average and show it with a picture. And box and whisker charts are really effective for doing that. I don't know if John Tukey thought of this when he devised the way he did the charting, but your attention should be focused on the middle 50%. They are the middle group. They are half of your data, and they're usually a more compact bunch. So where are they as a group, as opposed to just a single average? But they represent, in a broader sense, what middle is. But then also we need to understand who are the bottom 25%, who are with the top 25%, what do they look like? And showing them with whiskers seems to work. It's sort of secondary attention when you're looking at it. The only thing that I run into problems with is our eye gets really drawn to the outliers. That there's, what's that guy doing sitting way over there? Outliers are important to identify, but they're also distraction. And so that is one of the nice things in Excel and most other software, that we can hide the outliers. So we actually sort of produce two charts, one with the outliers in. Oh, they're there. That's important. Thank you for telling me. Now get them out of the way. So I do another chart without them. And it's great to be able to compare a whole bunch of groups concurrently. And there are some instances where we're comparing 10 or even 50 different groups. And this becomes a really quick way of getting to see what the pattern looks like. And charts are important. Charts, I like to say you feel a chart and you read a table. They affect the brain differently. They've got the same information, but the way we respond to them is very, very different. Where are we going here? Okay, so what I want to look at now is comparing two numeric variables. So box and whisker is a numeric variable and a categorical one. What if they're both numerical, that we want to look at the pattern between them? And that as we start getting into that, you're going to start thinking of building a model right away. You're going to jump to that conclusion, even though we could have built models for some of the previous stuff we've done. It's not the way you automatically think. So we're going to use a different data set. So we're going to stop using student data now. We may pick it up towards the end of the course. And we're going to look at one data set for 2 weeks now. It'll be credit card data. So that it would be looking at we're going to try to estimate, build a model. For 2 weeks, we're going to work at building a model to predict a customer's credit card balance based upon what we know about the customer. Why would you do that? Well, if I built that model that would sort of show, okay, if you're this type of customer, this is what your balance should be. It's like profiling. I know you could think of it as value estimation, you're picking a number, but I'm using it to define what is normal behavior for that type of customer. And it could be used to see, well, if I'd expect their balance to be $1,000, but they're owing $7,000, then there's something strange going on. Maybe this person lost their job and is living off their credit card now, and they're eventually going to declare bankruptcy, and we're going to be stuck with all that debt. So let's get after the customer and see what's going on. Or maybe it's the credit card's been stolen, and this is criminal activity that's taking place. So that might be an application. Sometimes we just want to understand borrowing behavior. And if you build a model, you'll generally find if you increase the customer's credit limit, they will borrow more. That may create a little more risk for the bank of them becoming bankrupt. But if you want to increase borrowing behavior for customers that, I get invitations from my bank on a regular basis to increase my credit card limit because I've been paying my balance on a regular basis. So I've been behaving properly. They want me to borrow more. So increase the limit, and it does encourage you to borrow more. But maybe I want to build a model so that I can work backwards and say, well, who are the customers that borrow a lot? So I built the model that says if you have these characteristics, this is how much you borrow. I could use it to go backwards the other way. And I'd like to know who are the customers that borrow a lot of money. There are a bunch of different things that I could do with such a model. This doesn't want to move on me. So the data set we're going to use, I found on a site called Kaggle. And if you're interested in data analytics, you may want to look at Kaggle. Kaggle has a variety of different things on their site to do with teaching you about data analytics. But they also run a variety of competitions for the people that are really, really keen on this type of thing. Competitions that are sponsored by companies that want you to build a model for them. They'll give you the data set, you build the model, and they'll give you prizes. And it's an alternate way than putting out a tender and asking for a consultant or someone to go and build models for them at a fee. This, you could have hundreds of individuals building models for you, and you only have to pay the one that gives you the best results, and you get to see all the other models that they built. It's an interesting model approach to contracting out. Anyway, that this data set is one that many people have used to play with to build predictive models, but it's not real data. It was created by a professor who was at the Marshall School of Business at University of Southern California, a fellow named Gareth James, written a very good book called Introduction to Statistical Learning. And if you go to his website, you can download it for free. It costs you a fortune if you want to buy it through Amazon. And now he just recently took a job as the dean of the business school at Emory University in Georgia. But it's not real data, but it sort of appears like real data. It's got a few. It was built for teaching. So there's the link if you want to download it. That I've also posted on our site. So what he's got is the last variable in the data set. There are 12. This is the data dictionary, if you like, for the data set, is what the balance is on the credit card. And then he's got, he's just coded them by ID. And the other 10 things that are there are characteristics of the customer. So what the customer's income is, and generally when you're applying for a card, they'll ask you about that type of thing. The borrowing limit that was set by the bank, customer credit rating, and those aren't set by the bank, they're set by credit rating agencies, but banks get access to them. They can also, through that rating agency, find out how many other credit cards the customer has. When they applied for the card, they gave their date of birth so we can work out their current age. More questionable is what's their education level, because generally not asked for, and it changes through time. You got the card when you were a student, and 10 years later, your education is different. And they did it in a strange coding fashion. They coded it from grade 1 through number of years of college or university. So it's a strange setup. Gender, I'm not sure if they're allowed to ask for that. In the US, they can ask for it, but they can't use it to make any banking decisions. So why do you need it? Whether or not they're a student, and again, it used to be credit card companies would push to get students to sign up and get cards. So they might know you're a student at time of sign up. But I said that status changes over time. So I don't think they've got that. Whether or not you're married, I'm not sure if they're even allowed to ask that. And what your ethnicity is. In the US, they do ask for that information, but they're not allowed to use it in any credit decisions. Well, so they say. Anyway, so we got this data set, and those are the variables we've got to work with. But in fact, after someone's had a card for a while, we have other variables we get. We know about whether or not they've had a late credit card payment in the past, whether or not they pay off their whole balance or pay the minimum balance, a whole bunch of different things about their payment history we would have in our organizational database, not just in your credit application database. So I'd like to look at how much they borrow and that how much they're carrying on their card. Now, the only way we've looked at variables before is look at different groups. So I could look at by gender or something. Let me look at credit rating. And I could group my data into different risk categories. They've scored your rating on a scale of 0 to 1,000, where if you're got a high rating, you're good risk, and if you got a low rating, you're bad risk. Okay? So I could go and use VLOOKUP and code my data, and I've done that. I'll show you it in a second. And I could create a box and whisker chart, and I'll do that in a moment. I'll just show you how we do all of these things in Excel. And we've done this before. So this we get that the high risk people don't borrow very much at all. We've got a few outliers in that group as well. Notice there's no whisker on the bottom of a box and whisker chart. That's because I got so many people reporting 0 as their card balance. And so they're all squished down at the bottom. 25% of my customers have a balance of 0 or more. That's why that thing isn't there. So you can see this is a very skewed distribution here. The medium risk, they're spread up. I've got some that have a balance of 0, but probably not too many. And it looks like the whiskers are about the same length. And the median, it looks to be about the middle of the box. So this is a very symmetrical distribution. This would look like among the medium risk customers, like a normal curve, a bell-shaped curve. And same with the low risk ones, they borrow more. Interesting. The lower your risk, the more you borrow. We'll look at that later. But why do I have to group the data? Why do I have to put it into different risk groups and then look at the balance? Why not just look at the data? So there I get what would be called a scatter chart. And so I'll show you how this is done in Excel. And so with my scatter chart, the higher the rating, up to 1,000, the higher the credit card balance. And you can see the pattern. You can see, whoops, excuse me. You can see how spread out it is. There's a lot of variability. So if you have a credit rating of 500, say, there's a big variability in your balance, anything from about $250 up to $1,500. A lot of variability. Whereas those with very, very low ratings, they're clustered together around maybe 0 to 200. And those with really high ratings seem to be more clustered between 1,500 and 2,000. Okay. But we knew there was a lot of variability in the box and whisker chart. That emphasized the variability you had in what was happening among those clusters. Anyway, if I wanted to understand the relationship between your credit score and your credit card balance, which chart do you think is better? And if you were in the on-campus class, I'd be asking that and getting people to answer it. And normally when I ask, I get mixed responses. Some people like the simplicity of the box and whisker, and they have an understanding of what it looks like. They look at how the boxes are going uphill. And others, they like the scatter chart because it gives them, they want that granularity, that detail of what individuals look like. So some people like one, some like the other. If you have a moderately sized data set, the scatter diagrams most people like. That if you had super large data sets, look at those dots, like look how concentrated they are here. Remember with the low risk or the high risk people that are over here, I said about a quarter of my data are sitting at 0. Can you tell that? Probably not, because they're just so, they're, all the dots are on top of each other. I can't tell that. And here they're all together. Imagine if you had not 400 values, but 400,000 customers. We'd fill in all this blank white space. There would be dots there. I'd be dots and dots and dots. This would just be solid blue, and I'll get some outliers more. So I'll get some dots way up high, way down below, and still a whole mass in the middle here that'll get filled in. My box and whisker chart should stay approximately the same because this is 50% of my data, 50% of 400,000 or 400. Same difference. It still just gives me a box. And the whiskers are just 25% at the top, 5% at the bottom. Again, it doesn't matter how many dots I've got to fill that in because I don't show them. I will get more outliers at the outside of the diagram because I got more data, but the chart stays the same. So with really big data sets, sometimes a scatter chart is hard to use. You can try fixing that in different ways. You could use a tinier dot, little pinprick, or you could say, I don't need all of the data. A chart with 1,000 values is good enough. 400,000 is overkill. So you might just use a sample of your data to do the chart. So different people use different approaches on that. So how do we do that? So in Excel, we need to tell it what the two variables are. What's on the horizontal axis, what's on the vertical one. Excel doesn't allow you to actually tell it that. It picks, you're picking two columns in your data set. The one that is on the left, it puts on the horizontal. The first one it sees is on the horizontal axis. The second one is going to be on the vertical axis. And beyond that, that's about all you need to start telling it. Okay, so I'm going to go and I'm going to select my two columns, credit rating and balance. Rating is on the left, so it's going to put that on the horizontal. Balance is on the right, so it'll put that on the vertical. And I'm going to go to insert. I'm going to go to charts. You can see up here that it has looks like a scatter chart up here. You could click on it and it'll choose it. I like to go to recommended charts. It'll give me a list of all the charts, and the first one it'll pick will be the scatter chart. Okay? And I click on it, and then I go and I try formatting it, because you'll see the way it formats it may not be the way I want it to appear. Okay? And the chart is to help tell a story. So help the story be told by putting words around it in an appropriate fashion. Okay? So before I look at others, let me go back and switch over here to that data set. So here is the data set that you got. I've gone and recoded to create this out of my way, to create those groups. That's how so I made it into a table. I created the different risk categories. Remind you, how do I build my box and whisker chart? I go and I select balance, select that column. I can go to insert. I can go to recommended and pick box and whisker, or if you've got this little insert statistic chart, or it looks like a histogram, it gives me a histogram or a box and whisker. I pick the box and whisker. Hello. There it is. Just slow. There it is. And then I go to select data, and I go to the horizontal category axis. I hit edit, and I go and take these different risk groups. Now don't click the label. Just click the first guy in that column to the last one. Go OK. So it gives me the different risk values here. I click OK again. I can't find my chart. I've got to go up to the top of my screen where the chart was. And this is what we had before. In it, I should change my title. And I'm going to be after you to start making more informative titles. So here that I can say that low risk customers borrow more. Don't say balance versus credit risk. That's not telling me anything. Tell me what the picture is showing you. What is the story you're trying to say? Okay? And it already has descriptors on the horizontal, but not on the vertical. So you might go to add chart element. I'm in design here, and axis titles on the vertical. It gives me a thing for title, and I'm going to type in balance. Okay. Now, I'm not sure if you can see that I've got here. Type isn't that big. If you're the sort that doesn't like to read up and down, click on it, right click, format axis title, and I think it's this guy. I can, oh, it's not, excuse me. Let me try this again. No, it's still not letting me do it. Back to it again and see if I can get it to work. No, normally it should allow me to change the direction of the text, but at the moment it's not. It's ghosting that out. I'm not quite sure. So I'll have to leave that to another time to figure out how to get that to behave properly. Now to make our scatter chart, I select credit rating, including the label if you want. You don't have to, you can, you can't. And over here I've got balance. So I've selected both columns at the same time. I go to insert. I can pick on the scatter chart or recommended charts. Scatter, there are a whole bunch of different ones. I want this guy, simple one. And if you've done it properly, the label for the variable on the right becomes the title. Okay? But again, I don't like this, so I'd like to say that customers with good credit borrow more, or with high ratings, something like that. Fix that up. Once again, here on the horizontal axis, I click on it. No, I don't need to click on it. I can just add in my chart title, excuse me. Axis title, horizontal. I'm going to have credit rating. Okay. And I'll go back and add chart element and vertical. And here I've got card balance. I wonder if I can, if it'll let me change the, there we go. See, this time it allowed me to do it. And I can look at text direction. I'm going to rotate it to horizontal. If you want to squeeze your box down, I think I can get it. It's not letting me do it. I like to go and make the box smaller, but it's not letting me do that. But I like my labels horizontal. It's your own preference. So that's how you do those different things. So let's go back to our slides here. Let's look at the other variables, because there are a whole bunch that are numeric. Now, some of them are categorical, gender, ethnicity. We'll deal with those at a later date. But today I want to look just numeric variables: income, credit limit, age. I've done all of the scatter charts here. Let me hide my face. And you'll see strong pattern here between rating and balance. We did that before. As income goes up, the balance also goes up, sort of, I think. If we set a high credit limit, they seem to borrow more. People with more credit cards, I don't know if they borrow more or less. Not really, really clear. How about their age? I've got people, there's someone that's 98 years old. But no, there doesn't seem to be much there. Old people and young people have a balance of around 0. Looks like they didn't lend anything to people under about 22 years old. And with education from grade 5 up to 20 years, okay. I don't see any pattern there at all. So some variables look to be related, others don't, okay? So if I'm trying to be making predictions of balance, maybe the top 3 variables will be useful, and the bottom 3 probably not, or not very useful. So how do you decide that? We did decide it by looking at a picture, but how would you say that there's a stronger relationship with some than with others? Can I measure that with a number? And yes, we can. The most common approach uses a formula, and it's based upon the idea of splitting your picture into 4 quadrants. So look at the mean credit limit. So this is credit limit data. It's around $5,000. The mean balance is around $500. So I've got people below average and above average in their credit limit, and below and above in terms of their balance. And I put pluses and minuses here. So this is above average in both. This is below average on the limit, but above average in the balance. This is below on both. And this is above average on the limit, but they didn't borrow very much. Okay. Now, if I was looking at the age and I split things, the average age was around 55 or thereabouts. And you see, okay, I've got lots of points in each of the 4 quadrants. Now I know the bottom quadrant, the balance is heavily skewed. We've got lots of people with low balances or 0 balances, and then the others are widely scattered, up to really high values. This data is very skewed on the balance side. So this one, the data is evenly spread in the 4 quadrants, whereas this one very concentrated in the bottom left, top right. And I could look at the variability of credit limits, variability of balances or age and balance. And variability in those variables is measured usually by a standard deviation. Okay. So how do I measure variability when I've got 2 dimensions? So I could measure, are you above or below average on each, and how much above and below average? That's the way we measured variance and standard deviation, was how much above and below average you are. But now I'm looking at 2 things. So instead of squaring my numbers, like I did before, which was just a convenience, how about if I multiply them together? What happens? Well, if you're in the bottom left corner, both are negative. Negative times a negative is a positive. And if you're in the top right, you've got a positive, you're above average and above average, you multiply it together, you're going to get a positive number. But if you're in the top left, you're above average in terms of your balance, but you're below average in terms of your credit limit. Or if you're in the bottom right, You're above average in your credit limit, but below average in your balance. They're opposite signs. When you multiply them, you get a negative. What happens if we then add all those things up? So remember variance, we added up the squared deviations. Well, now I'm going to add up products of these two deviations. I'm going to average it out. We aren't going to get into that mess. And it's called a covariance. And if it's positive, my numbers must be going up. I must be heavily in the bottom left, in the bottom, and the top right. If it's negative, I must be very heavy in the negative boxes. And if it's evenly spread, the pluses and minuses will all cancel each other out. So watch out, we can't deal with missing values easily here because then my formula doesn't work. So just an aside there. So covariance can be a negative number and it can be a positive number. Big positive means a strong pattern going up. Big negative, a strong pattern going down. But what is big and what's small? That's tricky. Depends upon the units you're using, depends upon the data set you've got. So maybe we should scale the data. And if you divide through by the standard deviation of the horizontal, standard deviation of the vertical, you get a thing called a correlation coefficient. And a correlation coefficient, it turns out, can only go from -1 plus 1. So the lowest it can go is -1. That's a strong negative pattern, strong downward sloping line. And a +1 is a strong upward sloping line. And 0 means nothing. The best way to understand these is to look at pictures. So if I look at these ones, that strong one with credit limit that we had has a correlation of 0.86. So it's fairly close to 1. Okay. And if I looked at income, where we thought it was going up, it has a correlation of 0.46. Did you expect it to be that high? I didn't. Anyway, I thought it would be lower than that. Pattern doesn't look that strong to me. If I look over at number of credit cards where I didn't see a pattern, or age where I didn't see any pattern at all, both of them have a correlation very close to 0. It's quite small. So it is giving me a loose indication. Okay. What about these patterns? If here's a pattern here I just made up, it's not in our data set. It's going downhill, but it looks like a pretty straight line going downhill. That'll have a correlation coefficient probably around -0.9. It's going to be pretty close to -1. What about these other guys? There's a very strong pattern here of goes down and then goes up again, or it goes up and then down again. So what sort of correlation would you get with both of those? Would you get something close to +1 or something close to -1? Well, no. Turns out coefficient correlation only looks at drawing straight lines. So if you looked at these guys, and I don't have my tools here for drawing, but oops, no, excuse me. If you could imagine me splitting the middle with a line across and splitting it up and down, and I split it into 4 quadrants, you are going to get them evenly scattered in the 4 quadrants. And they actually balance each other out. The correlation can be close to 0. The best straight line through this is a flat line. So the correlation coefficient only sees straight lines. And so what's the best straight line through your data set? These ones don't work. So if your data set has a strong pattern that looks like a straight line, correlation coefficient really helps. If it doesn't, if it has a strong pattern but not a straight line, correlation coefficient may fool you. So you have to be careful here. All right. That we can do this in Excel, find those coefficients, because doing it by hand is awful. But the columns have to be side by side to be able to do it. Okay, so you have to maybe move columns around so that it'll work properly for you. So if I wanted to look at credit rating and balance, I would need to move the rating column beside the balance column. Okay? That if I wanted to just look at all of the numeric variables, income limit, rating cards, age, education, all ones that are simple numbers, and balance, I can actually do all of them at the same time. So I'll bring up the correlation tool in Excel. I'm going to tell it where the data is, where the columns are, and the columns have got to be together. My labels in the first row, got to check that off. I'm going to put it on the same sheet so we can see it all at once. And I'll click OK. And this is what I end up getting. So let me see, how did I get that? Oops, let me get out of here. Back over here to Mr. Excel. So what I'm going to do, move these things out of my way here. Oh, no, that. There we go. Behind my controls. So I'm going to take income, limit, rating, risk, cards, age, education. I'm going to copy them. I'm going to put them into a new sheet. Oh, I don't want these words. Words aren't numbers. Get rid of this. Okay. I also need the balance. Put that in my new sheet. Okay. I don't know. Hopefully you can see all these guys. Okay. So now I'm going to go my data tool, go over to data analysis. Okay. And in the list, there's a thing called correlation. Click on it. It wants to know where's the data. My data is going from A1, top left corner, colon, then the bottom portion is in column G. The last row is 401. And I've got labels. Okay. I'm going to put it on this same sheet here so we can see it. So I'm going to click output range, and I'm just going to move it over to the side here. I'll put it in, say, in J1. Just give it the top left corner where you want it. Click OK. I get my results. Let me hide this stuff. And let's blow this up so you can see it better. So here are my correlation coefficients. And it doesn't, if I got it right, here we are, balance. Here we are, balance and rating, or balance and limit, I think. Sorry, not number cards. And limit. They're around 0.86. Both of them are. Okay. Remember, I said 0.46 was balance and income. Balance number of cards is only 0.08. Balance and age is only 0.0018. Really, really tiny. With education, it's actually negative, but it's pretty close to zero. So this shows me balance with each of these other variables. Balance with itself, perfectly correlated. If I know the balance, I know the balance. Perfect match there. And I can look at all the others and how they're interrelated. And some of them are interesting, that income and credit rating are highly correlated to each other. That limit and rating are also highly correlated. It's almost a perfect one. If you did a scatter chart of this, you're going to get almost a straight line. Very, very, very close to one. But these other guys, they're all pretty small. So that's how we get this thing pulled out. But to do it, notice I had to have all of the variables I wanted to compare all beside each other, and they all had to be numbers, no words in there. Okay. Let me get back here. So as I said, some have very high correlation, some are small, some may be negative. That we get quite a variety of different things. So we're going to leave it there. We're going to take this further next class and start actually building a model to predict balance. And as you might expect, I'm going to use credit rating to predict the balance because it's got such a strong correlation. That Now remember, with these correlation coefficients, they are trying to capture in a number what we saw in a picture, but they only measure correlation for straight lines properly. Right? If it isn't, it's not going to work well. And the numbers sometimes aren't what you think they should be. That with rating and balance, yeah, it was 0.86. That seemed reasonable if one was a perfect straight line. But the 0.46 for income and rating, that surprised me. That I find it difficult sometimes to guess what they look like. It's useful, I find, to have mental pictures, have a lot of familiarity with pictures and numbers so that you know, well, if I see a correlation of 0.2, what does that look like? Or a correlation of 0.7, what does that look like? That mental pictures are important to me because I'm a visual thinker on things. So what we're going to do next is start building a model, and I'm going to try to put a line through the scatter, and we're going to have to figure out what do we mean by the best line through the scatter. And then once I put a line through, how do I interpret that line? So we're going to start moving into a whole bunch of different things after that, and it gets increasingly complicated. Anyway, that's it. We're all done. Thank you.